Okay, welcome everyone. So today we'll be looking at the solution for the foundation track challenge for the Adebayo Network challenge of December 2025. So we're just going to fire up the devices now and just console into them. So I want to have my HQ PC here, the HQ switch, the HQ router, the ISP switch, the branch router, branch switch, branch. Okay, so that's fine. That's fine. So let's just go straight. We can download this data on the website and read this, or maybe try to configure it. So let's just go straight into this. So before you start, connect the NPCs as shown in the topology, which I've already done here. These are the NPCs, the HQ and the branch. So the IP for the branch is this. So let's just configure that now. IP 192.168.10.100.255.0 192.168.10.1. Okay, I think that's fine. And that of the HQ is 192.168.20.100.255. 192.168.21. I think this is fine also. Okay, so you can use the answer.docs documents to answer the question. I'll show you this data. So the first prompt is the user at the branch PC, that's this branch PC, cannot ping its default gateway. To separate, there are two configuration issues are causing this. Identify and fix them. Okay, so this cannot reach the gateway. Let's see 192.168.10.1, and it seems like it really can't reach the gateway not reachable. So let's see, the closest device to it is the switch. Let's look for where the gateway is actually located, if it's the switch or the router. So let's just show IP interface brief, and oh yeah, the gateway is here, and we can see it is administratively shut down. So that gives us a clue of what an issue is. So let's try to bring it up. If we show run VLAN, so we see it is shut down, and that's not fine. That's not fine. So let's try to bring it up. Interface VLAN 10, no shutdown. So with that interface should be up now. So we see, okay, it has changed to down. So if we do show IP interface brief, so we see now it is down. Now for the VLAN to be down, that is probably not passing anywhere. It's not being passed, and it's connected to E01. So, and we know that since this guy is on that subnet, it needs this VLAN here needs to be VLAN 10. So let's see what's going on there. Do show run. I just prefer doing this instead of typing out the long pipe since configuration is not much. VLAN 99. What's that? Do we have anything related with VLAN 99 here? I don't think we do, and even though we do, it's not correct on that interface. So we want to change this from 99 to 10. So let's go to interface E0/1 and let's do the switch ports access VLAN 10. So if we check that again, okay, so we can see notification that it is up. So this is up, and let's try to ping it again. Okay, after ERP it's up, it can ping, so that's fine. So with that, we've resolved the first prompt. So we did two things. What are the two things? We brought up the VLAN interface, the SVI, and we passed the VLAN interface. So to answer that question, this what we have here is a typical solution. So where is the fault located? On the branch switch. If it's located on multiple devices, you can add a command and say branch router also, but this one is only on the branch switch. The VLAN 10 interface was shut down, and VLAN 10 was not passing on E01 facing the PC. So this is a description of the issue. And remediation commands, interface VLAN 10, we entered the interface and we brought it up, and we also entered E01 and made it an access port with VLAN 10. So this fixed the issue. So I just like to show us this. That's a typical way of answering the questions. Okay, so now let's continue. After prompt 1.2, after restoring gateway reachability, you observe a high number of interface errors and power performance on the link between branch switch and branch router. Document the one connection fault issue. So with this, we can infer that, okay, this should be a connection issue. It should be a connection issue, and it's between this branch switch and the branch router. So the interface connecting them both E000. So let's see what's going on there. This branch switch, we have this duplex half. That's strange. Okay, let's see. Show run E01, E00 rather. So we can see duplex here. We have auto. So let's try to match. Let's try to match it on both sides. Interface E00 and duplex auto. I think we should have. Let's check the options we have. We have full, have auto, full auto. So we match it at auto, and this should be fine for this question. Actually, the auto is supposed to even be able to auto negotiate. So there should be a main issue if maybe there is full on one side and half on the other side. Okay, so the next prompt says traffic from the branch PC can now reach the branch switch, but it is failing to get to 10.10.10.2. So what's 10.10.10.2? Let's see. Do show IP interface brief. 10.10.10.1 is E01 on this guy. So 10.10.2 should be the IP on the other end, which is this. Okay, on the router. So can it reach 10.10.10.2? I think that should be possible. Yeah, that's possible because it can reach 10.10.10.1. It should be able to reach 10.10.10.1, so it can reach 10.10.10.2. So I think for this it can reach, but there is another issue. There's another issue that can prevent traffic flow on this device. So so we can try to investigate that. And we know that for any route, for any packets or for any traffic to leave this branch PC, it has to pass through its gateway, which is this switch, and that's fine. It has proper connection with its gateway now this gateway needs to route it to the router. The gateway needs to pass the ball to the router so the router can send it out. So let's see if this knows how to pass that ball to the router. So let's check the route configuration. Do show IP route. So we can see from what we are having here, we don't have a way of leaving this branch switch does not have a way of leaving. So we need to add a default route that if you are going out, pass the ball to the router. But before doing that, let's just check the configuration. Do show run. We have a route. Okay, so we have a route pointing to 10.10.10.20. Should it be that? Let's check the IP of the router. Show IP interface brief. So the router is 10.10.10.2. So probably this is a mistake here. It's supposed to be 10.10.10.2, but maybe a fat finger pressed the 20. So let's remove that. No, this. Then let's put 10.10.10.2. Okay, so let's check our route again. No, we do not see the route because that interface connection is actually not existing. So now we can see our route. So this is fine. So traffic can now safely leave this branch network and go outside towards the branch router. Okay, so let's go to the next prompt. And as we do all these things, of course, we document them, each prompt. We document each one because you're only going to submit this at the end of the day. You convert this to PDF and submit. Okay, so the routers at the end of the one link, branch and HQ, are unable to form an OSPF adjacency. There are two distinct layer 3 faults preventing this issue, preventing this from happening. Okay, so we are now talking about HQ router and the branch router. Okay. Show IP OSPF neighbor is bringing out nothing, so it can't form. So let's see what's actually going on. Let's inspect the OSPF configuration. So show run. Let's just filter this to include OSPF. Okay. So let's check on the other end and try to compare to an extent. Okay, so right here I can quickly spot something. Passive interface default. We know when an interface is passive, it's not going to try to establish neighbor using that interface. And on this round router, we're now saying all your interfaces should be passive because we have passive by default. So I don't think this is a good something. So let's remove that. Router OSPF 1. What's next? Router OSPF1. No passive interface default. Okay, so that's gone. Let's see if our OSPF forms. Though the question says 2 distinct issues, so we fixed one, and let's see what's going on. So the OSPF okay, we have router 83.3 here. We have router 82.2 here. Network 10.10.10. I think this should be the what's the point to point. Let's see which one is the point to point next. What's the point to point thing between them? Do show IP interface brief. On the branch router it is E01, which is this, and on the branch HQ router it is this. Okay, I need to verify their subnets. Okay, so on the HQ router it is /24, because you know in OSPF the subnets also matter. They have to be on the same subnets or prefix length. And here we have a /30. So of course this one's from adjacency. So let's see how to fix that. By default I'll just like to put /30 on the other end, but let's see the documentation. What was planned for that connection? By default it will just maybe like default. Okay, so you can see here /24 is the actual plan. So I think let's just continue with this /24. Well, even though 30 would be perfect for this, but let's just go on with what the documentation wants from us. So interface E01, IP address 172.16.1.2.255. Okay, I think this one is fine. We need to change on the other end. We need to change on this end. E00 connection to the that's E01. So IP address 172.16.1.1.255.255.255.0. Okay, so we've sent. Oh, that's fine. So you see our OSPF is up now. So do show IP OSPF neighbor, so you can see it can be full state. So with that, we've been able to resolve this issue. Okay, so that's fine. So the next one is this. It is now full, but HQ router is still not installing the routes for the branch user network this in its routing table. Wow. HQ router is not installing in its routing table. Let's see. Do show IP routes. Okay, we have learnt one route. We've learnt one prefix via OSPF right here, but we've not learnt the internal. So what could be this issue? Document the specific route filtering issue. Route filtering. So let's check our configuration again. To show run. On our OSPF, we can see we have a distribute list here. So let's actually go on. Let's go on and see what that distribute list is doing. So the name of the list is 1, right? So let's look for it. Okay, we have it here. So we have the access list 1 here. Deny. Why are we denying this prefix? So this is the prefix we want to collect. We need from the branch. So denying it right here is very wrong. It's very wrong. So we can fix this issue by removing this distribute list here, or by permitting this. So I'm just going to do the later one. I'm going to permit that. So access list 1 permits, or we can even delete the access list. Yeah. So I'm just going to permit it. Okay, so now we've permitted that. If we confirm, show run. Okay. Okay. So we need to delete this. So even after permitting it, it just went to the next line. So we have to remove this first deny that we have here, because right now if we still show our IP route, we still won't learn it because it is matching the first deny first. So let's remove that. Okay, we've removed that. So let's try to check our routes again. And beautiful, we can learn an external route here. We can learn the route here. Okay, so that's fine. So with that, we fixed this issue, and of course we document it. let's see if we can ping. Let's see if we can ping 192.168.10.1. That's the gateway. Oh, that's fine. Can we reach the PC? We can. That's beautiful. Alright, so from 3.2 says it has been reported that an engineer left a note on the branch router. Okay. It is leaked that this is a very critical piece of information. You will know it when you see it. It has the format ANC. You need to submit the content of that flag, and maybe it will help your troubleshooting too. Okay. So they left an important message. So let's see. Listing the directory. You can try to check these but these do not look like interesting files. Apart from that the other directories, what we listed now, we're in the system directory. We have other ones like disk 0, disk 1, and all of that. You can play with them and stuff like that. Another thing we can do is to check. Just there is actually there is not like a specific way of addressing this. It's just about playing around with the device and trying to look for maybe something that is abnormal. So checking the configuration, we can quickly spot an abnormality here in this loopback 1000. The description looks kind of weird. We are sent this long description, but it's still not what we are looking for, because they said it has to be in this format. It has to be in this format. But looking at this, it can trigger us to think, because to me it looks like this is an encoded something. So normally it might not end like that, but most times it leads to equal marks, leads to like point attention towards something. But you don't just put your mind on that. It might not end like that sometimes. So let's check base 64 and try to see if we can decode that. There are other sites that you can go to and just paste something like this, and it's going to suggest to you that this is base so this is bit code, this is no, this is Morse code rather, this is Morse code and stuff like that. There are sites that I'm not going to mention, but with some search we can always get that. So okay, so I'm just going to paste this here. Why? Oh, okay, so I think we have what we're looking for now. So we can see it's this format. It says very easy lab. Okay, so I think this is what we're looking for. So for that particular prompt, this is the solution. This is the solution. Just pasting this. That's the solution for that. Okay, so the final. Oh, are we done? That's quick. The final verification: after applying all fixes, provide the outputs of a successful ping from branch PC to HQ PC. So what's the IP of HQ PC? That's 20.100, right? Okay, so let's try to ping from branch PC and see if everything is cool. Timeout. Okay, we can ping. So we just screenshot this. And also I think I saw like one screenshot also, like maybe I think you're trying to ping from the same device or the same device, but of course we are going to know, because one of the things I'm going to check is the TTL. We know what TTL does, so, and I know how many layer 3 ops we have in this lab. So if the TTL range is not matching, so we know TTL can have different stuff depending on what we're trying to ping, but if it's not matching the range, we'll know that okay, there's probably an issue or something here. For this one now, I believe for this one probably is around 255, and after passing through one up it drops to 254. For this one I believe is around 64. After passing through about 4 ups it drops to 60. So pinging from the branch, it hits here, it hits the gateway here, it hits here, hits here, that's third up, and hits here, that's about 4th up, it drops to 60. So from the TTL we can do all these calculations. So if you just send the screenshots that it's not the real thing, we'll still know, because we actually go through all of them. Okay, so that's the first verification. The second verification is provide the output of show IP route this from the HQ router. So let's see. Show IP routes 192.168.branch.0. Okay, so we can see we can learn this via OSPF. The metric is 0, the administrative distance is 110, and we can see all of that information. So we take the screenshots also and paste it in the documents. Paste in the documents and the completed documents. So with that, everything is fine. And convert your Word document to PDF before submitting. That's very easy. If you're on Windows, you can just print, Control P, and change this to print to PDF and print. That's all. Or you come right here and click on export and create PDF. And okay, you create PDF and click on the create PDF right here, and it's going to convert it to PDF for you. So that's the end of this session. Thank you so much for joining. We're going to see you later. Bye.